G'day guys. I think I better turn this down. It might be a little bit loud because I've got another microphone sitting on the detector. Let's drop the threshold a little bit. Been doing a lot of experiments on these older detectors, and yeah, um, even so, you think you know everything, you never do. I'll tell you that right now. it's it's amazing. I've back engineered, gone forward, gone back, check this, check that. There's so much. There is just so much. Anyway, um, starting to think about things in a different way again, as you do when you go back and examine what's been done, how it's been done, everything in the past. Not just my stuff. I'm talking everyone's stuff. Just about every metal detector manufacturer out there have sort of sat playing the same game, or the same game plan, should I say. And yeah, I just sort of dug a little bit deeper and had a look at the overall noise uh, in these detectors, where it comes from. Um, there's a lot of stuff well, we call it intermodulation. What it basically means is a mixing of either wanted signals, unwanted signals, more likely unwanted signals into what we want, and it causes um, basically the signal to go, well, what you want to go backwards. Basically, I'm trying to say it in simple speak. It degrades the signal. Um, So we want to get rid of the intermodulation. We want to check out things like power supply rejection on all these detectors, like this thing down here, which I've got a 5000 sitting there at the moment, just humming away, doing its thing. And I'm just trying some outrigger boards. I've got some new chips in. I'm trying them as well. Uh, there's plus and minuses in the ICs. But one thing that playing around with some settings. I don't know if you can see on the oscilloscope there, but I've got that set up at 300 megahertz bandwidth, and we're looking at the receiver input stage output. This probably won't make a lot of sense to many people, but I'll tell you, it's a really good thing to look at when you understand what it is. If you actually look at the baselines there in the middle of the screen, well, you probably can't see. I'm probably too high up in the air. I'll go down there and I'll try and zoom in a bit so you can, whoops, there you go. Need a camera operator. If you have a look at that there, it may look like a big blurry mess. It's actually not. That's on 5 millivolts per division. And those horizontal lines is the actual signal, well, actually receiver turn on, and signal rides in that as well, mainly on the leading edges, but in this part here. But the less furry it is, say for a simple word, furry, the less furry it is, and it looks pretty furry, doesn't it? That the less furry it is, the less noise overall, and the more resolution and the more signal you get into the detector to be able to do something with. Okay, if I just take this up a little bit, have a look at this here. Say we go to something like that. That's 20 millivolts per square division. You probably can't even see the squared divisions. Oopsie. Scale, there we go. I hit the wrong one. I don't even know if you can see that. That's scale illumination. I don't think it'll show up on the camera. It hardly shows up here. But basically, if you look at the screen, broken up into little square segments, and horizontally it's just time segments, and vertically it's how many millivolts, volts, or whatever per division. So if we look at 20 millivolts, and you can see these little lines here, there, that there's not much, they're not very fat up and down. They're not very fat, which means that there's very, very little noise in the whole system. When you have these things with just normal, standard low noise op amps, or what people think is low noise, they're really fat, and they actually obscure target signals in the noise. So within reason, the thinner, the better. You want everything to be nice and clean. Really, you should amplify this probably by 10 or even maybe 100 times and get right in on it. Make up a separate amplifier and just, look at your previous preamplifier and, just magnify it just by giving it 10 or 100 times extra gain, and you can have a look at it very, very in depth. But we don't need to do that, because considering what's in these things to start with, the noise is roughly about 20 millivolts peak to peak, and we've got it down to about 5 millivolts with massive sensitivity, which is a huge boost. So we'll just go up here. I'll probably zoom out again, else you're all going to get car sick. So up we go. Whoops. You got to be like an octopus. You got to have a few hands to do this. Okay, I think we're level-ish. I'll lock that off so it doesn't go screaming down and fall over. So the thing is, what are we in? We're in normal mode. Normal mode again, okay? Now this is no boost board, nothing of that nature. This is just changing a lot of componentry, to say it politely, to shut the thing up, okay? That these detectors do, and I know for a fact, the stuff is from Intermod, the power supplies aren't the best, and there's just noise all through it. But anyway, you can clean it up. There's ways and means. So we've got this little specky tiny thing here, which the writing's rubbed off on 0.025, not 0.25, 0.0025 of a gram. In other words, a speck. So you get this, and like I say, I don't know if anyone really wants to dig these things up, but you can do. So you can dig that up. The other thing, which is absolutely extremely important, is ground balance with these detectors. When the ground balance is out, it'll either enhance hot rocks and possibly degrade the response from gold targets. So ground balance is quite critical. I used to think it was a bit rubbery. It's not. It is quite. It has to be accurate. It's got to be spot on. So if we get a hot rock, now I'm working without being able to see what I'm doing as usual. So it probably will track. I'll just track it. It won't track because I've probably got it on very slow tracking. I'll just flick it, give it the fast track without tripping over everything. Yeah, I've got on slow tracking, but anyway. So it totally tracks out hot rocks. That's in normal mode, by the way, which is really difficult to do, especially this is running very high frequencies, by the way. So it's really hard to do. when you run really high frequencies on these detectors, you're getting to the edge of getting the return signal from hot rocks, hot ground, getting back into the receiver. And that stuffs everything up. You can't have that. So where I've got it actually set at the moment, I'm rather amazed that it's as quiet as what it is. It's really quiet. It means basically tidying it up and getting rid of all the loose ends is a good, simple way to put it. And it's working really, really well. It's very, very punchy on big gold, or bigger than these little tiny flecks. Like I say, you can adjust the detector to get pinheads if you want or less, or you go the other way and you can have it go really, really deep, running great whopping coils, lower the frequency, and yeah, you can run in normal mode. At normal mode, it just works beautifully. Um, when you have a look at it, all the first detectors within reason, well, except for the SD2000, that ran 4 smaller pulses and 1 big. Then when the 2100 came about, it went to 3 smaller pulses and 1 big. And that just basically gets you more sampling over a given time period, because you've got one less larger pulse in there. So, but when you have a look at the designs, there's someone turning a light switch on. I know that. It sets off the detector if someone turns a light on and off. And I think the light out there, which is a really noisy, horrible fluoro thing, I think someone's turned it on, but the detector doesn't care less at the moment. It's just not responding. So that's where we are with this at the moment. Bigger targets, not a problem. Let's get something decent. Something decent. I'm joking. Let's get something decent, like 0.05 gram. Like I say, this is running very, very narrow. I'm running a narrower bandwidth than what these detectors normally do. That's to get the noise down. And the thing is, what I'm trying to get across here is, like, even the 0.05 isn't a huge screaming signal like we have had in the past. The thing is to understand that the total near lack of background noise lets that stand out, even if it's very, very soft. Like, actually, you have to move it to get a signal, but I mean, you're not going to miss small targets like that. And when you get up to 0.1, which is, I think a 0.1 is probably something fair to go after. 0.0, it's really, really tiny, tiny stuff. I can't swing properly because of the way I've got the ruler. So if I'll move the ruler over here a bit. That might make it easier. That's better. Even around about 8 centimeters, you can still hear it. It's just a slight bit of noise. I could probably turn the threshold right down to just about 0 and it'd pop out a lot better. But what we're doing is improving the signal to noise ratio. Just remember it's normal mode, and if you have a listen to it, it's not pop, 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 burble, burble, burble in the background. It's not doing anything like that whatsoever. Now, when we go into other modes, let's go into the notorious fine gold mode, which look, I looked into this, right? I'm going to say this. This is my opinion, but it's probably pretty accurate. When the 4500s were put out, the input stage gain was 48. Okay, it had 10 ohm resistor, not on the non-inverting input to ground, or basically we'll call it ground, which is ground. I don't know what else to call it. I call it ground. But when and also a 470 ohm was a feedback resistor from the output back onto the junction of that resistor and non-inverting input. So it caused a feedback control over the IC, and it basically 47, 10 into 47 plus 1. So basically 48 times. But when fine gold came out in the 5000 detector, the input gain has been reduced down to 34. So it's a 330 ohm resistor in the feedback network, a 10 ohm to ground, and the junction there is where that feedback from the output goes. So that in itself is giving you a gain of 34. So we've gone from 48 to 34 in the front end gain. And in my opinion, the only reason that was done is so fine gold would work properly. That's it, probably the only reason. And don't quote me on that, because it might have been a reason to say it's a quieter detector, which they did say is a quieter detector, and it is a quieter detector because it has less gain. It has less amplification in the front end, so it's not going to pick up a lot of fringe interference. It's going to be less, but in the same mode, does that equate to less depth in the other modes, especially normal mode on Big Gold Deep? Does reducing the gain have that bigger an effect, or does it not? Now, what I've done with these, like a lot of experimentation, is I think that it actually has fairly minimal effect overall. It does have an effect, but it's not as great as what you'd think. You can't sort of think, well, we're going from 48 down to 34. That's a big drop off. Actually, not really. You can get extra depth running more gain, but you'll also bring up the noise. So you can take it right down if you wanted to. You can have a gain of 10 and run a 100 ohm resistor as your feedback resistor, but then that does start really affecting the gain. What is the way to go with this? And this is what, well, I've known for a long time, but I've been trying to retain the gain. But the thing is, with these new upgrades that I'm doing, I'm using extremely low noise op amps. And I'm not just using one, I'm paralleling. I'm getting down to about 0.32 or something of a dB noise figure. I mean, that is super low. That's basically 3 times less than standard. Okay. But then we go taking our resistive losses. That's why I do changes on the input MOSFETs and all the switching FETs. I try and, you need to get rid of the capacitance. You've got to get the on resistance as low as possible. So that's a trick in that area. And you've got to also get rid of a lot of the intermodulation distortion. There's other areas in these detectors that can be greatly improved. And yeah, on this one I have, because it's so damn quiet. This is my test one. It's had a hard life. It's had stuff taken in, taken out, all the rest of it, and it still works quite well. But the thing is, say we have that much. Well, we'll go to the point one. we're still getting up around 8 centimeters. Um, could have been a little bit higher in the other videos, but there was all this pop, 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 all the local interference coming in. Out in the field, it probably wouldn't be an issue. Now, like I say on this detector here, I've really pushed it. There we go. The old, you've been working on it too long. You've been working on it for 8 hours, and the battery's going to go flat. But before it goes flat, I'll put it into fine gold. Let's flick it into special. Fine. That's only the 0.05, 0.05, and we'll go to this little tiny thing here. So I'm thinking about giving these detectors a spread of a very, very, very low noise front end. I mean, we're talking a noise figure of lower than probably a 50 ohm resistor. That's what we're talking about here. And by saying that, I actually have to use resistors below 50 ohms. But anyways, it's difficult to do, and it's a bit of a juggling act, but we can do it. And yeah, like that's plenty of grunt. But then we put on our amplifier stage and give it the variable gain, or we can put another amplifier on this and take advantage of that very, very, very low noise front end. Very, very low indeed. So yeah, that's where we're at with our new lot of experiments. Like I say, if you have a look at the front boards there, yeah, that's how loud the amplifier is. It's really loud. On the front boards there, I've only got 2 chips on it because I'm only testing these new chips. And just for everyone's, I don't think you can actually zoom in with enough resolution to read the numbers because I haven't got them rubbed off. But they're new chips. I got them in today. David brought them around about 4 o'clock, and I couldn't wait to try them out. So just having a look at that shot on the oscilloscope there will show you that it's absolutely super clean waveform. And the other thing to take note of, I've got to go down. Gee, I give away a lot of information, don't I? Especially to competitors and that. But hey, you guys benefit, so big deal. If we actually have a look at this, I'll show you something on here. I might have to zoom in a little bit. And yeah, you've got to hate that. It just says you've been working on it too long. That's what it's saying. So let's go down here, and we want to go. Yeah, we're on full bandwidth. Okay, 100 millivolts. There we go. Oops. I might have to turn up the intensity so you can. It's going to blur everything out. Okay, but we're on DC. I'm trying to find. I'm not looking for the big spikes. I'm looking for the small ones. Where are they? 20 millivolts. Okay, I'm going to turn this down just so I don't have to compete with it. Actually, how about I just turn it off? No, I won't turn it off because then you won't be able to see what I'm pointing out. Funny about that, eh? On these detectors, there's a lot of artifacts. You can see there, that's the power supply there. But when the receiver or when the power supply um, turns off and the receiver comes on, you can see these little spikes. Usually they're very, very pronounced on the standard detector. They're very, they can go up to probably about, I don't know, maybe 2 volts per, on the vertical. And yeah, these ones here, I've got them down at 20 millivolts. That's really, really suppressed. So that, I've noticed that you start getting rid of these artifacts, even though they're out of the out of the receiver passband, they actually improve the overall noise of the detector. So some things tickle other things, I'd say, and it may cause a ringing effect and come in when the receiver's turning on. We don't really know what goes on because, you know, on this detector, as it's covered in white paint, you don't know the whole circuit. We know a lot of the chips and stuff, but you know, we don't know every value resistor, capacitor, and you know, all that sort of stuff. We just, it's a big job. You have to go through and measure it all and then back engineer it and draw it out. What happens in the microprocessor type stuff, that's just bare bones basic. It's not as complex as people think. It really isn't, in my opinion, just in case. But yeah, that I'll try and this thing will carry on if I try and do this. It doesn't like mixed signals. Even oh, there we go. But how about I go by 10? Yeah, you can see here on the start of where the receiver come in. See all that stuff wiggling around there? You get this effect, you know, up, down, up. There's a little bit of ringing, but it is suppressed. And you can see here on the main waveform, we've got this on 10 times at the moment. We'll go down a little bit closer. Hopefully it stays locked. No, behave. There you go. That's at 5 millivolts, really spread out. You can see all that sparkly stuff there. That's just random noise. That's like if I touch the input there like that, you can see the random noise. That's just, that noise is just picked up off the cables. If I actually had this boxed up, it would be a lot less noise overall. It just gets in there. So even testing here and having it an open framework, when you put it all back together, it's better than what it was. So that's interesting in itself. You can go skirting along here, and we can have, you know, you can have a look at things turning on. You got this spike here as a dip beforehand, and even there where it turns on, there's a little bit of a lag. You can see all that, and this is sort of stuff that you got to take in, and you know, try and keep everything flat and nice if you can. But the power supply on this, on the input boards, I've got to bolster it up by a couple of big caps. There's something about that as well, which we can go in at a later date. And just about the bypassing, you know, there you are, right there. You can see all that, you know, the power supply switch off. I don't think it switches off super clean. I don't think you can. You need a lot of snubbering to keep it clean. And if it's not in the passband of the receiver, who cares? Within reason. Then you have a look at the power supply itself. You know, there it is there. You can see like that zoom right in, 5 millivolts per division. But if you zoom out, it's not that staggered. You know, I don't think it's that bad. Well, because it's outside the passband, I don't care if it's a bad power supply design. It doesn't make any difference. But if we zoom out, I'll put that back down because I'll get it off 10 times. It looks ridiculous. But as you see, what do you want to make sure here that the power supply, even though the receiver's turned off, you want this decay line here straight. You don't want it to curve up. As soon as you get any curving on that line, it basically is telling you something, what's happening to your actual receiver on time, and it is stuffing things up. It's very hard to see because it's very, very fast, but yeah, see, I can see it there. I can see all the little spurious little switching lines there, but this thing's so damn bright you can't really tell. I go down. What are we on now? That's looking at what mode am I on? Oh, dear me. Well, it's in fine gold, so I don't know what part of the waveform that is. But you can see that is the receiver input, and you can see the furries on it. Now, with these detectors, I don't know if you can, what I've got looking at, but you can improve things a little bit by playing around with the feedback capacitor. And even better still is if you are using the right op amps, you can use a compensation pin and play around with capacitor values on that compensation pin to try and get rid of some noise. You don't want to reduce the bandwidth too much because you could be sitting there and you say, well, I'm doing this. I put on, on the feedback capacitor, I put on, 2 nanofarads, okay? The waveform will look beautiful. It'll be crisp. It might be just sort of like 1 millivolt per division line type thing. And you'll go, wow, look at all that. And you may tweak it up by playing with the compensation pin to ground, or also you can do it to ground and you can also do it back on the input. But anyway, on the output. The thing is, you've got to take into account that you do all this and you say, wow, look, it's basically, we're looking at DC. Try and ground balance. They won't ground balance in a million years. This is where people get tricked. You can clean up all your waveforms to a point and then you go too far and it won't ground balance. And you also got to compensate for if you're going to run an extended clocking rate, and then if you clock it too fast and you've got it's set up so it's going to get rid of a lot of the noise, it won't ground balance. So you have to back it off so you can. This is where you could push these detectors and really push out the performance in particular modes of operation. But remember what I said about the 5000 with fine gold. It will not work very, very well if you run it at the same gain as what's in a 4500 and you come up with some really hot ground. It will not ground balance at all. It must be just the receivers coming in so much faster than the other modes. In my opinion, I've always got to say in my opinion, because it is my opinion, right? Yeah, we don't want legal letters coming in. We got to say my opinion. So that being that, you can play around with a lot of stuff in these and get them behaving quite well. But first thing you got to do, and you can do this if you want, I'll say there's ICs in there which are good. They're good, but there are better alternatives if you do things right. So yeah, I'm not saying. Well, basically, I'm talking about the AD797s. They're first developed as an audio chip. They're basically a low noise audio chip when they were first developed, and they are low noise. They've got some interesting characteristics, by the way. But you can have a look at other ICs. I mean, I bought thousands of dollars worth of ICs trying out different ones. You think that they're all much of a muchness? They're actually not. They're not at all. Especially when you start, bypassing and stuff like that. Some have absolutely atrocious power supply rejection, and other ones are really good. And there's all these trade-offs between all the parameters of these chips. You know, you can have really low noise, but then you can have high distortion. You can have very, very low drive current. You can have huge amounts of drive current. That will also limit your slew rate, stuff. It can't switch fast enough. You lose small signals. It goes on and on. There's distortion runs up. You're trying to drive something else, and it's loading the output stage. It's so much in there. You have to you can model it, by the way. You can go use Spice programs and model it. But I found in a lot of cases, computer modeling, in many, many cases, does not equal real life. There's just too many variables. So that's that. Sitting there, that's, yeah, we've got a 300 megahertz bandwidth from this, and that's 2 millivolts per division. And like I say, it looks very furry, doesn't it? But it's an absolute massive improvement than what they are standard. Really, there's a lot of things, like I say, you can do. I'm not going to go into all of them because some of it was unique discoveries, and yeah, what will happen if I go and tell every person out there, it'll all be turning up everywhere. But some stuff you don't want to give away. You want to keep it. You want to keep some of it to yourself. But I'll tell you what I'm going to do. I'm going to do this, and because I've waffled on for so long, anyone who first tuned in then tuned out will not know about this, so they're going to miss out, which I love doing. I really love doing it. What I'm going to do, I've got a couple of spare detectors, and I'm going to give one the complete treatment. As in, it's only going to, I'll either use a GP Extreme. If I actually use a GP Extreme, it'll be a really, really good detector. Oh my God, will it be an improvement on what that detector is standard? It'll be massive. It'll keep up with everything else too. Not a problem. It will blow the pants off a lot of stuff. So how about at some stage, I've got to organise this how to do it, but I'm going to do one up and absolutely make the bee's knees detector, and to a lucky subscriber, I'll give it away. Like I did with the opals. Uh, yeah, gave two batches of opals away to people that subscribed. So how about a detector? I'll make a real doozy too. I mean, this thing, I could optimize it. So, well, actually, how about we just give it the whole lot? We go the smallest of the smallest gold, handle any ground, and the biggest of the biggest gold, handle any coil. That might be the way to go. Just go full tilt on it, and just make an absolute doozy. It will be good. I can even have an independent test on it if you really want. But a lot of people don't like videoing, and they don't like showing their face, and that then you just lose credibility because you don't know who it is and what it's all about. You put your face to it. Don't be ashamed. Do that. So that's going to be one that's coming up, but it's only going to go to a subscriber because otherwise I won't know who to select and send it to. I don't care where you are in the world, as long as you're in a subscriber thing. Maybe if you're a subscriber, I'll have to get you to. You might have a subscriber that's not interested. Maybe they run around with a, Garrett or something. I got no idea. But yeah, it would be an absolute doozy of a system. I'll have to talk to Dave too, see if we can put some add-ons with it as well. Like, I don't know what we can put on it. We can put battery system, lithium battery system, booster. Make a real big package. Make it really good. And yeah, and not someone who just wants it for to collect. I want someone to use this because I know it'll bloody be good. It'll be fantastic. Yeah. So, what do you think of that? Look, I got a couple of brand new 3500s too. Uh, I could actually do one of those up, but oh my God, I love the GP 3500. And even so, if I actually did up a GP Extreme, I'd love that more. But then again, if I did the 3500 up, I'd love that more than the Extreme, even if it was done up. So yeah, it's yeah, I could even go full out and do a GPX 4500 and give it away. I've got about, I don't know how many of those I've got, 3 or 4 or 5 kicking around. But see how we go. Um, yeah, we can make really, really good detectors because we've got the basic building blocks, and all we need to do is fix it up, make it better. Modernize it is a proper word. Modernize it with modern componentry and make it go really, really good. So let me know your thoughts on that, guys. Put your thoughts down. Tell me, what sort of detector do you want? Do you want an absolute, or specifically something that just picks up pinheads? Or do you want something that goes really, really deep? Because there probably is a little bit of optimization either way, but you can incorporate a big spread as well. So let me know what you guys think, and I'll see what I can do. I can work magic, and yeah, that we can do. Anyway, I think I better charge my battery. It's probably going playing that little tune in the background. There we go. Power supply goes to negative and comes back up. Whoop, there she goes. I've noticed on this oscilloscope too, it's got a little bit of an offset when you have it on 2 millivolt scale. Might have to get in there and fix that. It's probably just a trimmer or something, but oh, maybe it's coming back up. But every other mode on it's fine. Anyway, no big deal. This time I'll turn. Oh, by the way, my amplifier I was using in the previous videos, I didn't realize this, is actually the audio amplifier chip at some stage. I think I might have actually dragged something across. I did. I dragged solder across it, and it let out a really loud crack bang sound, and it still worked. I didn't think anything of it, but I noticed that um, it actually had a serious problem. That's it there. Where are we? There we go. That's the one I was using, and I've got a new one there at the moment. I actually blew the audio chip up, so I've got to replace it. And you've been listening to all my videos with a blown up audio chip. It never had the dynamics it should have had. Oh, dear me. Like at the moment, this thing here is about 4 times as, maybe 4 times as peaky. If you put a signal over it, it's really, really booms. But yeah, because this one here, which I'll undo it. I'll show you basically. Oops, here goes a roll of something. Undo that, undo that. Oh, there we go. Yeah, I'm using this one here. This one's good too because I usually leave the battery on. This one's got a red light on it, so it tells me you left the battery on. Please turn the battery off. But this one here was one I did ages ago. I've got a Bluetooth transmitter on it and isolation transformer. And the thing is, these Bluetooth things, they want to work on 3.3 volts. And this, because it's got AAs in it, only 3 volts. So I had to use a little, oops, there we go, a little step up boost board that converts 3 volts, or basically anything from 2.7 to 3 volts to 3.3. So what a convoluted way of doing things, just because of, yeah, the technology 3.3. Why can't it just be 3? It would have worked fine. But yeah, you could. I did that ages ago, and I don't like it. I don't like that Bluetooth because there's too much multipath. I think I did a video. I don't know how many years ago I did a video. Might have been 7 years ago, and I was getting multipath distortion, and I said, nah, not good enough. So when we got the new Bluetooth standards, they actually have some intelligence that they can negate multipath distortion and all that sort of stuff. So, like El Cheapo Asian karaoke machines. If you move the microphone around strange, you get funny multi-path signal effects uh, as the RS signal just basically bounces off anything and returns at a different phase, and it goes crazy, and you get that, that sort of a sound. It sounds like that. Anyway, that's enough. I'm nearly over the COVID, but I've got a dry throat now. I've been yammering too much. Well, actually, I'm over the COVID. Stupid bloody COVID, Jesus. Um, what a what a what a laugh. That's why you don't touch lift buttons and eat food. There's a moral to that. Anyway, catches.